Hello, and welcome to this lesson on corrosion. In today's lesson, we will begin by defining corrosion and exploring why it is a problem for materials. We'll pay particular attention to iron corrosion, commonly referred to as rusting. Then, we'll touch on methods taken to reduce rusting. So far, we've explored various properties of materials and their uses. We've also looked at the periodic table and learned about different types of chemical reactions. Building on this foundation, today's lesson will deepen our understanding of how chemical reactions, specifically corrosion, can affect materials over time. This concept is crucial as it helps us understand the long-term durability and maintenance required for various materials, especially metals. Corrosion is essentially the gradual degradation of metals through chemical reactions with their environment. This process leads to significant issues such as reduced durability and compromised structural integrity. It involves the oxidation of the metal, typically under the influence of air and water, but can also include other chemicals. A specific type of corrosion, known as rusting, particularly affects iron and its alloys, such as steel. Rusting requires two essential components: oxygen from the air and water. When iron encounters both water and oxygen, a chemical reaction occurs. The iron reacts with oxygen and water, leading to the formation of iron 3 oxide. This iron 3 oxide does not stay as a compact protective layer. Instead, it forms as rust, which is brittle and flaky. Rust is a weak, porous material that doesn't protect the iron underneath. Instead, it easily flakes off, exposing more iron to the environment and continuing the corrosion process. The presence of water significantly accelerates this reaction. In fact, iron won't rust as quickly in dry conditions. To help illustrate this, imagine a nail made of iron. If you leave this nail outside where it's wet and humid, you'll soon see rust forming on its surface. Compare this to a nail kept in a dry environment, and you will find that the latter doesn't rust nearly as quickly. Think of corrosion as a silent attacker that gradually eats away at metals. Rusting is just one specific but very common form of this broader problem. Understanding this concept is crucial since corrosion affects everything from small household items to large infrastructures like bridges and ships, impacting their functionality and safety over time. By grasping these key points, we recognize the importance of taking measures to prevent or slow corrosion, ensuring the longevity and safety of metal objects and structures. Now that we understand why preventing corrosion is important, let's look at some methods used to protect materials from corrosion. First, we'll look at barrier coatings. Barrier coatings are applied to a metal surface to prevent air and water from coming into contact with the metal, which could cause corrosion. There are several types of barrier coatings. Next, let's discuss greasing. Applying grease or oil is one of the simplest ways to protect metal surfaces. It creates a physical barrier that prevents moisture and air from reaching the metal. Using paint to cover the metal is another common method. Paint forms a protective layer that shields the metal from the environment. For instance, cars are painted to prevent rusting. The final barrier coating method we are going to discuss is electroplating. This involves coating the metal with a thin layer of another metal using electrochemical processes. By placing the metal in a solution containing ions of the plating metal and applying an electric current, a protective metallic layer is formed on the surface. For example, steel objects are often electroplated with chromium to prevent rusting. Next, we'll look at oxide coatings. Some metals, like aluminium, can naturally form oxide coatings. When aluminium is exposed to air, it reacts with oxygen to form a thin, protective layer of aluminium oxide. This oxide layer is self-healing, meaning if it gets scratched, new oxide will quickly form to protect the underlying metal. This prevents the aluminium from further reacting with environmental elements and corroding. Finally, we'll look at sacrificial protection. Sacrificial protection involves using a more reactive metal to protect the less reactive one. One common example is galvanization, where iron or steel is coated with zinc. Zinc is more reactive than iron, so it corrodes instead of the iron. Even if the zinc coating is scratched, exposing the iron, the zinc will continue to corrode first, protecting the iron beneath. This method is widely used on outdoor structures like bridges and fences to prevent rusting. Each of these techniques employs a different strategy to protect metals from corrosion. Barrier coatings prevent contact with corrosive elements, oxide coatings create a natural protective layer, and sacrificial protection uses a more reactive metal to safeguard the primary metal. Understanding these methods helps us choose the best approach for various applications, thereby extending the lifespan of materials and preserving the integrity of structures. By applying these methods, we can avoid the costly and potentially dangerous effects of corrosion. In today's lesson, we delved into the concept of corrosion and its impact on materials, particularly metals. We focused especially on rusting, a specific type of corrosion that affects iron and its alloys, such as steel. This process requires the presence of both oxygen and water, leading to the formation of iron-3 oxide, commonly known as rust. We discussed how corrosion leads to significant issues such as reduced durability and structural integrity. Finally, we outlined methods to protect iron and its alloys from rust, such as barrier coatings, oxide coatings, and sacrificial protection. By understanding these key points, we recognize the importance of preventing or slowing corrosion to ensure the longevity and safety of metal objects and structures. This lesson has provided us with a clearer understanding of how and why corrosion occurs, its specific impact on iron, and the broader implications for material maintenance and safety. Watch the rest of the GCSE chemistry course at Sophos Education.